So for number 52 from that multiple choice packet, it says the equation of the tangent to the curve x squared equals 4y at the point where x equals -2. So we're looking for the tangent to this at x equals -2. So that gives us 5 points. So first thing we need to do is we need a point and we need a slope. So it's up to you guys if you want to find the point or the slope first. I think it's probably might as well just find the point since we've got the equation. -2 squared equals 4y, or 4 equals 4y ought to tell us that y equals 1. So we've got the point -2 comma 1 is the point at which we're looking for the tangent. And then we need to find our value for dy dx. And I mean, we could just do this implicitly, or we could just make this y equals x squared over 4. And that would give us our dy dx equals 2x over 4, or just x over 2. And we need to evaluate that at x equals -2. So we don't even actually, we don't need the y value to plug it in. We're just going to need it for our final equation at the end. And so if we plug in -2 there, we end up with the slope of what? -2 over 2, which should be -1. And so we should get y minus 1 equals -1 times x minus -2. And that probably is not what any of their equations look exactly like. So it looks like they've got everything. No, most of them they have solved for 0 there. Let's just distribute this all out. Y minus 1 equals -x. That's a +2, but then the -1 makes it a -2. Let's see. If we solve, let's just solve for 0 because most of them look that way. Y plus x plus 1 equals 0. Is that one of the answer choices?
It's E.
It's E. Wonderful. Look at that. We did it. Everybody good there with 52?
Yeah.
Wonderful. All right. So the next one somebody had asked about was number 65. Let's see. 65 says there are 2 tangents that can be drawn from the point 3, 5 to the parabola y equals x squared. And we want to figure out what their slopes are. Okay, so in order to figure that out, we kind of got to think about what the equations of those lines need to look like. So the equations of those lines should be a y minus a y1 equals an m times an x minus an x1. Right? That's just how we do those. And our y1 and our x1 will be 5 for y1 and 3 for x1. So we'll say y minus 5 equals our slope times x minus 3. And what is the slope of the tangent? Well, the slope of the tangent is the derivative, which would be a value of 2x. And so we then need to go in and plug in 2x for our slope. Y minus 5 equals 2x times x minus 3. And from that, we should, let's see here. Since we know that y is equal to x squared, we should be able to go in and replace the y with x squared, giving us x squared minus 5 equals 2x squared minus 6x. Right, that's our parabola. We know they have to be tangent to the parabola. So we know that y has to equal x squared. And so that gives us x squared minus 6x plus 5 equals 0, which should give us x values. If we factor that, x minus 5 and x minus 1 equals 0, or x equals 5, x equals 1. And if x is 5 and x is 1, well, the slopes should be 2x evaluated at x equals 1 and x equals 5 should give us values of 2 and 10. Which, I don't know, I didn't actually look at that. Yeah, choice C. Oh, good. How'd that go? Everybody feel okay about that?
Wait, what'd you do with the 5 and the 1 to get? Oh, you plugged it into the derivative?
Right, we got, yeah, so we solved this and said these are our x values. Well, the slope is 2x, so we just
Oh, I see.
each by 2. Yep. Any other questions on that one? No, everyone good there? All right, next one, which is the last one that somebody had asked for yesterday. I'm happy to do other ones today, though. Is number 80. So number 80 says we've got a vertical circular cylinder. There's our cylinder. Has a radius of r. Okay, cool. Radius of r has a height of h. That's even better. And both h and r are increasing at 2 feet per second. And we want to know what is the rate in square feet per second at which the lateral surface area increases. So lateral surface area is just the surface area of the part going around it, not including the two bases. And so your lateral surface area is always, we'll call it A, is equal to 2 pi r, that's your circumference of the base, times the height, right, for a cylinder. And so we'll just go in and take the derivative of both sides of this with respect to t. And the derivative of r times h, that's one function r times another function h, so that should be the product rule, r times dh dt plus h times dr dt. And dA dt then should be 2 pi times, and then dH dt is 2 and dr dt is 2, so 2r plus 2h, which I guess it looks like choice C if you factor the 2 out. So 4 pi times r plus h, choice C. Any questions there on number 80? Okay. Any other questions from any of the applications of the derivative multiple choice that we did not do yesterday? Okay, 82. All right, and then we'll do 6 right after 82. So 82 says we got 2 cars traveling along perpendicular roads. Okay, we're going to have an intersection, it looks like. Car A is going 40 miles an hour. Car B is going 60 miles an hour. At noon, car A is at the intersection. Car B is 90 miles away, moving towards it. At 1 p.m., we want to know the rate at which the distance between them is changing. Okay, so we're going to put A here at noon. and B we'll put up here. So we're going to start with B here. We're going to start with A here. A is moving in this direction away from the intersection. B is moving in this direction towards the intersection. Okay. So we'll call this distance y, and we'll call this distance x. Is the distance x getting larger or smaller?
Larger.
Should be getting larger, exactly. So we will say that we've got dx dt equal to 40, positive 40. And what about dy dt? It should be a negative 60 because that distance of y is getting smaller.
When did the question specify that car A turned? Or are we just supposed to assume that?
That it turns? No, I didn't make it turn. It says two cars are traveling along perpendicular roads.
Oh, I assumed that like car B was behind car A. Oh, I see. Okay, okay.
Yeah.
I see. Okay, yeah.
At least that's how I read it. I don't know. I mean,
No, it's probably right because then it's 10 times easier to come up with an equation.
yeah. And so at 1 o'clock, we want to know how the distance between them is changing. So that's this distance. We'll call that z. We're looking for dz dt. And we then also need to figure out what is the value of y at 1 o'clock and what is the value of x at 1 o'clock. To start with, we might need to figure out the value of z also. So if A is traveling 40 miles an hour, in 1 hour, it ought to go 40 miles. And car B is traveling 60 miles an hour, and at noon it was 90 miles away, so it's gone 60 miles in that hour. It should be 30 miles away now. Everybody good with that? And using the Pythagorean theorem, we should be able to relate those. We'll take the derivative, 2x dx dt plus 2y dy dt equals 2z dz dt. And we've got x, we've got dx dt, we've got y, we've got dy dt. We don't have z, and we're looking for dz dt. So we should be able to find z really easily. Right? 30 squared plus 40 squared equals z squared. So what is z? That's just a 3, 4, 5 right triangle, right? Z ought to be 50. So then we just plug it all in. 2 times 40 times another 40 plus 2 times y, which was 30 times negative 60 equals 2 times 50 times what we're looking for. And just solve for dz dt. So what is that? That's 1600 times 2 is 3200 minus 3600 equals 100 dz dt. 3200 minus 3600 is negative 400 divided by the 100 gives you, looks like negative 4, whatever the units were, miles per hour, right? Everybody good with that? 82 should be, looks like D.
Yeah.
Everyone good there? No questions on that? All right, number 6. Okay, number 6 says the equation of the tangent to the hyperbola x squared minus y squared equals 12 at the point 4, 2 is and so all we have to do is, if we're looking for the equation of the tangent, find a slope and find a point. We have the point. So to find the slope, we'll just differentiate this implicitly, which will give us dy dx. If I bring that over and then divide by the 2y, just equals x over y. If we evaluate that at the point 4, 2, that equals 2. So it should be y minus 2 equals 2 times x minus 4. And that's not what any other answer choices look like. So we'll distribute y minus 2 equals 2x minus 8. Still not any of the answer choices. Y equals 2x minus 6. That's an answer choice. Choice C. Is everybody good there with number 6? Okay, that's all I've got on the list now. Anybody else have any other questions from those multiple choice problems? Going once. Going twice. Anybody?
I don't remember what Rolle's theorem was, and I was looking through my notes and kind of wanted a review on what that is.
Yeah, sure. Rolle's theorem. Rolle's theorem is just a corollary to the mean value theorem for derivatives. So the mean value theorem for derivatives says that, yeah, if you look for the average rate of change, so this is just the mean value theorem, f of b minus f of a over b minus a. The average rate of change on an interval of a function somewhere is equal to the instantaneous rate of change on that interval, or some c on the interval a to b, if the function is continuous and differentiable on the entire interval. So that's the mean value theorem, right? So basically it's saying that if I have a function that's continuous and differentiable from a to b, that the average rate of change, so whatever the slope between these 2 points is, there must be at least one place between a and b. There could be more than one, where the instantaneous rate of change, where the tangent line slope is the same as that slope between the endpoints. Good with the mean value theorem?
Yeah.
Okay, so Rolle's theorem then says it adds to this f of a equals f of b, which tells us that there must be a place on the interval where f prime of c equals 0. There must be at least one critical value between a and b. There must be a place where the derivative equals 0. And it's just saying that because f of a equals f of b. And so then that tells you that the numerator of that fraction for your slope is just 0. So you've got 0 over something equals the derivative. So that's just a special case of the mean value theorem. So everything else must still be true. You have to have a continuous function. You must have a differentiable function. And f of a must equal f of b. That tells you there's a place where the derivative is 0 on that interval. Does that make sense?
Okay, so then on the AP test, how would they work this into a question?
They might say something like, here's a function, and they would say verify, they might say verify Rolle's theorem on the interval 2 to 7. And then you'd have to show that f of 2 was equal to f of 7. And then you'd have to find the place where the derivative equals 0.
Okay, got it. Thank you.
Does that make sense? Yeah? Yeah.
Mhm.
Cool. Good, good, good. All right, let's see. Somebody put something in the chat here. Okay. Okay, that's not a question about So anybody else? Any other last second questions there on the applications of the derivative multiple choice? Or just in general about applications of the derivative before we move into our next free response questions? All right. So our next set of free response questions that we're going to be working through and having a quiz on next week will be differential equation ones. So this is the first one we're going to do. Usually the differential equation questions, there's two different types of differential equation questions. One of them has to do with slope fields and the other one generally doesn't have to do with slope fields. And so we're going to practice some of each. And when we do the quiz for this, for the differential equations for response, I'm going to give you one that's slope fields and one that is not slope fields. Usually though, what you'll need to do is do something with the slope field, if it's a slope field one. And then there'll be one other part that's something else that's a little bit different, that's not exactly related to solving the differential equation. And then there will be one part where you have to go through fully and solve the differential equation given some initial condition and and solve. And generally the part where you find a particular solution to your differential equation with an initial condition, part C in this one we're about to look at, usually is weighted the most heavily in that question. So sometimes that's worth up to 5 or even occasionally up to 6 points for finding the particular solution, depending on the points they assign to the other parts of it. So that's worth a lot. So this is the first one we're going to work on, and I will give you all 15 minutes to work on it, and then we will work through it together. Sound good?
Is this by any chance up in the drive or no?
I don't know. I don't remember if I did. Let me see here. No, it doesn't look like I did because I don't even have a PDF of it saved.
Okay.
Oh man, I didn't mean to save
fine,
that.
yeah.
No, I didn't mean to. I just saved all those extra pages of work as like my regular document now. What do we need here? Pages 7 to 13. Okay, I'll have it up there in just a second. So I'll give you guys 15 minutes to work on it, starting now, and then we'll go through it in 15 minutes. It should be up in the Google Drive in like a minute. Ready to go. Well, let's start with part A. So they've given us the slope field. Sometimes they'll give you the slope field and ask you to sketch solutions. Sometimes they will give you a blank graph and ask you to sketch the slope field. So in this one, you got to sketch your own curves, but not the slope field itself. So we're going to sketch the solution curve that goes to the point 0, 2 first. That one should be pretty straightforward. It should go from left side there. Didn't end up looking very good, but no ideas. Pretend that looks good, right? 0 to 2. All right, at 0 to 2, straight horizontal line. So that's worth 1 point. That should have been an easy point, I hope. And then through 1, 0, you just kind of follow the trajectories here. So it should go up to there, should kind of come down here and then go up like that. And if you got both of those, that's 2 points. And the specific criteria that it says they must go through the indicated points. So we did that. It's got to follow the slope lines. Okay, well, we generally did that. If yours isn't perfect, it's okay, but it needs to look about like that. And it also says that they need to extend to the boundary of the slope field. So if you're ever asked to sketch the solution through the slope field, make sure you extend it to the boundary of what is given to you. So that's 1 point and 1 point.
If you put little arrows on the end of them, would that be incorrect since it like extends past the boundary of the slope field, or is that like fine?
I think if you put an arrow, you're probably okay.
But don't do it in the future.
Yeah, but don't do it in the future. Yeah, because you don't, this only represent, I mean, okay, I'm sure that it starts to look similar as you go. I mean, sure, it looks similar as you go further from whatever those values are, like past x equals 3. But, and you could figure that out by using that differential equation that this is the slope field for. But based on what's drawn, this is what it should look like. It shouldn't go any further than the boundary. All right. Part B. Now, part B doesn't really have a lot to do with the differential equation itself. It just says, let f of x be the particular solution to the given differential equation with some initial condition that f of 1 equals 0. And so that'd be the second one that we sketched. We want to write an equation for the line tangent to f of x at x equals 1. And we want to approximate that value. So first off, if we're talking about this is our initial condition, right? That should then tell us that the point we're looking at is 1, 0. And what would the slope be? How do we, because that's what we need to write a tangent line, right? We need a slope and we need a point. Well, we've got the point, 1, 0, f of 1 equals 0. And the slope we should be able to find by plugging in x equals 1, y equals 0 into dy dx. dy dx equals 1/3 x times y minus 2 squared. We need to evaluate that at 1, 0 to find our value for our slope. Does that make sense to everybody? Because the derivative, dy dx, represents our slope. And this is probably the most common sort of not exactly solving a differential equation question that you'll see. So usually the like non-differential equation part is talking about a tangent line equation for the graph of our function.
So this part had nothing to do with integrals, or like you didn't have to anti-differentiate it or anything like that?
You did not need to anti-differentiate anything. You had to recognize that. So f of x is the solution to our differential equation. We want to write a tangent line to f of x. So a tangent line to f of x requires a point on f of x and a slope of f of x. Well, the slope of f of x is its derivative, which is this differential equation. Because f of x is the solution to the differential equation. So the slope of f should be its derivative or the differential equation itself. Does that make sense?
Yeah.
Okay. And so then we'll plug in the 0.10. So we got 1/3 times 1 times -2 squared, which gives us a slope of 4/3. And so we would write y minus 0 equals 4/3 times x minus 1. And that's our equation. And the equation itself is worth 1 point. And then they wanted you to approximate f of 0.7 using it. So that's just a matter of doing 4/3 times 0.7 minus 1, which is -3/10, which would give you 4/3 times -3/10, or looks like -2/5. Or you could have left it as a decimal if you wanted -0.4. And that was the second point for part B. So part A had 2 points, part B had 2 points. Any questions on parts A or B? Everybody okay with parts A and B?
Yep.
All right. So part C, we had dy dx equals, what was it, 1/3 of x times, was it y minus 2 squared, I think?
Yeah.
Okay. So part C asks you to now find the particular solution to this differential equation with this given initial condition. So now we need to integrate. And so in order to integrate this differential equation or to solve this differential equation, we need to separate the variables. So this becomes dy over y minus 2 squared equals 1/3 x dx. And right there, immediately, that's 1 point. All you have to do to get a single point is separate the variables. Put your dx on the right, put all the y's on the left. That's 1 point. Then you integrate both sides. Integrating both sides correctly gives you 2 more points. So the integral of y minus 2 squared, that's just u to the -2. And since the coefficient on the y is a 1, that u substitution ends up being really easy. It just becomes -1 over u. So we end up with -1 over y minus 2. So that's worth a point. And then integral of 1/3 x ought to be x squared over 6. That's a point. And you need to put a plus c on one side or the other. So just putting the plus c sometimes gives you the point, but in this case, it did not give you the point, a 4th point. You need to then use the initial condition that when x is 1, y is 0 to try to solve for c. And if you make an attempt to solve for c, then you're going to get a 4th point. So we'll plug in -1 over 0 minus 2 equals 1 squared over 6 plus c. Just doing that gives you a 4th point. So this should be 1/2 -1 over -2 should be a half equals 1/6 plus your constant, which should tell you your constant is a half minus a 6. That's 3/6 minus a 6, which is 2/6 or 1/3. And then you need to go back and solve for y to get the 5th point for part C. So I'll just go to a new page for that. We had -1 over y minus 2 equals x squared over 6 plus 1/3. And so then you need to solve for y. So we talked about this a lot when we were doing our separable differential equations and had fractions over here, but you got to get a common denominator here if you're going to take a reciprocal. So now we've got -1 over y minus 2 equals x squared plus 1 over 6. Sorry, not x squared plus 1, x squared plus 2, because I multiplied that by 2. Now you can take your reciprocal, -y minus 2 equals 6 over x squared plus 2. And then divide by your negative. And add 2. And that's your 5th point.
Can you go back to the previous page real quick? And you said even if you attempt to solve for C and you don't get it right, that's still a point?
That's the way it seems to indicate it to me on the scoring guide. It says,
Sweet.
the 4th point is constant of integration and uses initial condition. Now, I'm not sure if, I assume that's puts the plus C and uses the initial condition to try to solve for C. And then I think they assume that if you can get the correct C, you should be able to, solve for Y and get the 5th point. So even if you get the wrong, you knew the right thing to do, you might have made an arithmetic error and got the wrong C, so you can't get the 5th point for getting the final solution, but you can at least get the point for showing you knew what you were supposed to do to get this.
So C was just like loaded with points, whereas all the others were like pretty minimal.
Right, and that's what I was saying at the beginning, is the one where you actually solve for the particular solution is generally weighted to at least 5 out of the 9 points of that one, usually. Sometimes it's 6 even, occasionally. I've seen one where it was 7. Wow. Every once in a while, it's only 4, but it just depends on what the other parts are. But I would imagine, if you get one of these, you should expect it to probably be at least 5 points.
Okay, thanks.
Yep. No problem. Any other questions on that one? How do you guys feel about that now? Feel like
Starting to
that you-
remember how you're supposed to do it. So
yeah, now that you've done one, maybe you'll
Yeah.
do better with the next one. This one is very different. We're not going to do this one today. We'll do this one next time. This one is pretty similar. So I'll give you guys a nice, easier one to look at right now. And let's see, we should have time. I think we'll have time to go through all of this. So here it is. You have 15 minutes to go through this one. Ready, go. So for part A, you just had to sketch the slope field at 6 points. First off, anywhere where y was equal to 0, you should have had a slope of 0. So that'd be here and here. Having 0 slopes, the correct points that have 0 slopes, it was worth 1 point. And then for the other ones, you just needed to plug in your values. So y was 1, x was 0, should be 1 over -1. And as long as it looks pretty much like -1, you should be good. Y was 1, x was 2, it should be +1. So as long as it looks about like +1, you should be good. And then y is 2 and x is 0 gives you -4, so pretty steep. Doesn't look very good. We'll call that good enough. And then same thing here, y is 2, x is 2, gives you +4. So the other slopes, or the others, is worth 1 point total. Hopefully everyone got part A. Part A was pretty straightforward.
do you have to show your work, like you plugging in the values and then what you got, or no?
Nope, you do not. Exactly. I mean, you don't even need to write 0 slopes and whatever. I mean, anything that if you just drew the 6 things, you're good.
We don't need to draw like the rest of the curve.
You don't need to draw anything else. It says sketch the slope field. All you need to do when it says sketch the slope field is sketch those 6 points.
Okay.
Usually 6 is the least I've ever seen. Usually it's more like at 8 to 12 points. And usually if there are 0 slopes, some that have 0 slopes, that getting all of those correct is worth 1 point, and then getting the rest is usually worth another point. Usually.
So this was worth 2 points?
2 points for part A.
What's the 0 slopes part? Is that just
Well, these have a slope of 0, so they're
just getting those specifically is 1 point? And
Yeah.
Okay, I see. Okay, yeah.
all right. For part B is very similar to the last part B that we had. We want to write the equation of a line tangent to the graph of f, where f is the solution to this differential equation with the condition that f of 2 is 3. So we have a point. Point is 2, 3. We just need a slope, so we'll evaluate this at 2, 3, which ought to give us 9/1 for a slope of 9. So our equation should be y minus 3 equals 9 times x minus 2. And that right there is worth 1 point. And then approximating it at 2.1. Is worth the other point. So that's 0.9, and you're going to add the 3 to it to give you y equals 3.9. And that's a 4th point. So parts A and B there, I hope, were pretty easy, especially after just doing the last one. Hopefully so. All right. Part C then asks us to solve this differential equation, which was, what was it, y squared over x minus 1. So again, 1 point if you just separate the variables. So dy over y squared equals dx over x minus 1. Again, 2 points here for correctly anti-differentiating. So y to the -2 becomes -1 over y. And 1 over x minus 1, if you do the u sub on that, ends up becoming natural log absolute value x minus 1. So 1 point there, 1 point there. You need to put your plus C. And once you put your plus C and try to solve with your initial condition, you get a 4th point. So our initial condition was, what was it? F of 2 was equal to 3, is that right? Or F of 2 is equal to 3. So we're going to plug in 2 for x. Natural log of 1 plus C is equal to negative 1/3, giving you a constant of negative 1/3. So doing this work down here to solve for your constant is worth a 4th point. And then go in, plug in your constant, and solve for y. So we should end up with negative 1/y equals natural log absolute value x minus 1, so minus 1/3, right? It was minus 1/3, yeah. Okay. And so once again, we're going to need to get a common denominator here to take the reciprocal. So 3 natural log absolute value x minus 1 minus 1 all over 3. Then we'll take our reciprocal. Negative y equals 3 over 3 natural log absolute value x minus 1, and we'll divide by a negative. So we'll call that y equals negative 3 over 3 ln absolute value x minus 1. Or if you want to distribute the minus through in the denominator and make it 1 minus 3 ln absolute value x minus 1, that's fine. Any of that's good. You didn't even have to get the common denominator. If you wanted to, you could have just said, you could have just done this. You could have said negative y equals 1 over this. I mean, I think the way we did it is a little cleaner, but this would be fine as well. So y would be, you could write it as 1 over 1/3 minus natural log absolute value x minus 1, or just a negative, you keep them the other way. But any of those are fine. One way or the other, that's the 5th point. Any questions on that before I let you guys out of here?
Do you need to indicate any domain restrictions at all?
You do not. If it doesn't specify that they want the interval of validity, you don't need to put it.
Okay.
Yeah, so
And then if
they always in the scoring guide make a note. They say like, oh, this solution is valid for whatever, but you don't actually need to put it. So
okay, thank you.
no problem.
If I didn't put the absolute value in the natural log,
I cannot hear what you're saying.
can you hear me now?
Very faintly.
Okay. If I didn't put the absolute value in the natural log, would I get points off?
Yeah, you got to have the absolute value there. If you don't have the absolute value, they will take off the point.
Okay.
And then no plus C, somebody said that in there. And we did the plus C here, right? And solve for the constant. And so once you solve for the constant, you go back in and replace it and then solve for Y. So there's no longer a plus C because we found that constant. Does that make sense? Okay. Cool. All right, that will be it for today.